Our early solar system, a chaotic dance. Our solar system wasn't always peaceful. Imagine a cosmic billiards game with planets forming from dust and gas. These young planets were constantly bumping into each other. Some collisions were minor, others were catastrophic. Our Earth was about to be part of one of these massive collisions. What happened next would change our planet forever. Theia, named after the Greek Titan, was no small fry. It was a protoplanet in its early stages of formation. This wasn't going to be a glancing blow. This was going to be a head-on collision. The stage was set for a cataclysmic event. The Giant Impact, a cosmic cataclysm of unimaginable proportions. The collision between Earth and Theia wasn't just a collision, it was a planetary demolition derby. The energy released was unimaginable, a force so powerful it defies comprehension. The collision vaporized Theia and a significant portion of Earth's surface. Temperatures hotter than the surface of the Sun were generated. This wasn't a quick crash, it was a prolonged event. Debris from both Earth and Theia was ejected violently into space. Enough material to form a ring around Earth, a ring of chaos. This ring of debris would eventually become the building blocks of our moon. The aftermath, a cloud of debris. The colossal impact changed our solar system. Trillions of tons of molten rock blasted into space. A superheated ring of debris formed around Earth. Particles constantly collided. Collisions caused particles to stick together. This process, called accretion, forms planets and moons. This was the beginning of our moon's journey. Section 5. Birth of the Moon, from chaos to order. Within the chaotic cloud of debris surrounding Earth, a new celestial body began to take shape. This was a time of intense cosmic activity. Gravity pulled particles together, forming larger clumps over thousands of years. The debris coalesced into a single molten sphere, glowing brightly. This fiery molten body was much different from the moon we know today. Over millions of years, the molten moon cooled and solidified. Its surface crinkled and contracted, forming craters and mountains. Tidal forces locked the moon into synchronous rotation, shaping both celestial bodies. The moon's profound influence. The impact that created the moon reshaped Earth. It melted Earth's surface, forming a global magma ocean. This ocean cooled, forming the first continents. The moon's gravitational pull stabilized Earth's rotation. This stability was crucial for life to develop. A breathable atmosphere, a gift from the moon? Here's a fascinating idea. Some scientists believe the moon's formation played a crucial role in Earth's atmosphere. The giant impact likely blasted volatile elements into Earth's early atmosphere. These elements are essential for life today. Over millions of years, Earth's atmosphere evolved to the oxygen-rich composition we breathe today. Isotopic evidence rocks from the moon tell the tale. How do we know about this ancient collision? The key lies in the rocks brought back from the moon. These samples have been meticulously studied by scientists over the years. These rocks have a remarkably similar isotopic composition to Earth rocks. This supports the idea that the moon formed from material blasted off Earth during a giant impact. The isotopic match is crucial evidence for the giant impact hypothesis. Section 9. The Giant Impact Hypothesis, solving the lunar mystery. The idea that the moon formed from a giant impact is the leading explanation for the moon's origin. It explains the moon's size, orbit, and composition. While some questions remain, the giant impact hypothesis is widely accepted. The moon's enduring impact, tides, seasons, and life. The moon's influence extends far beyond its formation. Its gravitational pull creates tides, shaping coastlines and marine life. It stabilizes Earth's axis, giving us distinct seasons. Without the moon, Earth would be different. The moon is an integral part of our planet's story. The moon as a time capsule. Studying the moon is like looking back in time. Its surface preserves a record of early solar system events. By studying lunar craters, rocks, and dust, scientists learn about ancient conditions. The moon holds secrets about our planet's formation. Unlocking these secrets deepens our understanding of the cosmos.